morning, good afternoon, good evening to our lecturer, Dr. Ilamaran. Today, we will be presenting about the sustainable energy for rural communities based on the site we chose. These are the table of content. They include introduction, the site description, proposed design, economic impact, environmental impact, as well with the conclusion for both of the sites. Access to reliable electricity is essential for improving living standards, supporting education and healthcare, and enable economic growth. However, many rural and isolated communities still lack stable and affordable energy, which limit opportunities and affect quality of life. The usage of fossil fuels will bring harm to the environment through greenhouse gas emission, highlighting the need for cleaner and more sustainable alternatives. Renewable energy offers an environmental friendly and cost-effective solution, especially for remote communities that are far from the national grid. According to the International Energy Agency, latest finding, more than 745 million people worldwide still live without access to electricity, particularly in developing areas of Asia and sub-Saharan Africa. In this project, two rural locations were selected for renewable energy implementation: Long Sebaya in Sarawak, Malaysia, Port Maturin on Rodriguez Island, Mauritius. Both areas experience limited energy access but have strong natural resources. Long Sebaya, with its flowing river, suitable for micro hydropower, and Port Maturin with abundant sunlight, ideal for solar system. So for the first site, Long Sebaya, it is a small rural settlement located near Long Napel in the Limbang division of Sarawak. As you can see from the bottom picture, the area is surrounded by dense forest and hilly terrain, and it sits roughly 70 kilometers away from the nearest town. Because of its remote location, access to basic service is limited. The nearest city, Limbang, is almost a 3-hour drive away, and the closest hospital can take up to 4 hours to reach, especially during bad weather or road closures. Using Google Earth, we have estimated the population to be around 360 people. Many residents operate small guest house and camping areas, which are popular with visitors. For the cultural aspect, Limbang itself is culturally diverse, with communities such as the Malays, Lung Bawang, Bisaya, Murut, Iban, and Chinese living together. So, the Long Sebayang hilly terrain and continuous river flow make it highly suitable for micro hydroelectric power. Hydropower systems rely on elevation difference to generate water pressure, and the slope around the village provide the necessary height, which in this case is about 13 to 15 meters. Combined with steady rainfall, the river can supply a reliable and renewable source of energy throughout the year.
Thank you, Jemarco. Good morning, everyone. I'm Siak Chun Shi, and I'll be talking about Port Maturin. So Port Maturin is the capital and administrative center of Rodriguez Island, which is located 553 kilometers east of Mauritius mainland. As of 2022, it has approximately 8,004 residents, with a gender distribution of 52 to 48 male to female ratio. As for the age distribution, most of the population are of working age, but it indicates a young but slightly aging trend. Port Maturin houses multiple heritage, including African, French, and Indian, and the primary language is Rodriguez Creole. The terrain goes from flat to slightly undulating with volcanic soil, which is suitable for both housing and commercial infrastructure. However, as it is located near the coastline, it is exposed to heavy rain, erosion, and cyclones. For this project, we've located a small village, which is located approximately 1.5 kilometers northwest of Port Maturin, which is approximately 60 households in the area, housing around 240 people. The proposed design for the village is the rooftop solar PV system. We suggested this idea as Port Maturin has abundant sunlight throughout the year. The government also actively promotes renewable energy adoption to reduce fossil fuel dependency and improve energy security, especially in remote areas. Other than that, solar PV systems are already encouraged at community scale, making the solution socially and economically aligned. Rodriguez Island receives around 12.46 sunlight hours per day, with approximately 5 to 6 peak production hours, which meets the minimum solar requirements. This means that the energy generation remains efficient and reliable year-round, and is highly suitable for renewable projects. As for the calculation, we assume that a 1 kilowatt PV system is used for 5.5 hours per day. The usable output per day is approximately 4.7 kilowatt hours per day, and the total capacity for 60 households is approximately 115.3 kilowatt for 5.5 hours per day. This energy can be stored in batteries for nighttime consumption. For the system components, each household consists of a rooftop photovoltaic panels, which is mounted at optimum tilt angle, an inverter which converts DC to usable AC electricity, a charge controller which regulates charging cycles and battery protection, a lithium-ion battery bank which stores energy for night and cloudy periods, wiring, breakers, safety disconnects, and mounting frames. The benefits of implementing the solar PV system as it provides reliable power supply, especially at night, and improves the quality of life. Other than that, it saves costs and lower carbon emissions in the long run. Lastly, it adheres to Mauritius' national renewable energy goals. Now I will pass the time to Clement.
Alright, let's focus into the river characteristic. Based on the data given from the hydrological data from JBS Public, it shows that the Limbang River has a water level ranging from the 0.9 to 7 meters. At the intake location near Long Sebayang, is an estimate depth of the 0.3 meters is used for the calculation. It's a conservative value to ensure that the design remains safe during dry season. And another data from the Sarawak hydrology study, the Limbang Basin has an average flow velocity of around 3.5 meter per second. This indicates a medium slope river with a stable and fast flow, making it suitable for micro hydro energy extractions. Our micro hydro design uses a very simple, efficient run-off river concept. The water from the river is first channeled through an intake structure into a small canal or forebay. This helps to stabilize the flow and removes the sediments. The water then travels down to the penstock pipe towards the powerhouse, where it strikes the brakes of the turbo turbine. The turbine drives the generator to produce electricity, and the water is returned to the river with a minimal disturbance. This design avoids the large dam, making it suitable for the rural area that want to protect their natural river ecosystem. We propose turbo turbine because this turbine is designed for the medium head and moderate flow, which matches the Limbang River's conditions. Its efficiency requires little maintenance and has a compact shape. Based on the flow rate of the 0.063 cubic meter per second and the head of the 12.5 meter, one turbo turbine can produce about 6.25 kilowatts of power. This amount of energy can supply essential electricity to about 80 households. To support all 360 residents of Long Sebayang, we estimate that 12 turbo units with a total installed capacity of around 75 kilowatts would be required.
To implement a micro hydroelectric system in Long Sebayang, several key components are required. First, the water turbine converts the kinetic energy of flowing water into rotational energy. This rotation then drives the generator, which produces electricity for the village. A control system is also needed to regulate voltage and frequency, ensuring that the power supply remains stable and safe for the community. In addition to the equipment, manpower is also a major economic aspect. Skilled workers are required to transport the components to the site, perform installation work, conducting civil works, such as building the intake, the penstock. Engineering consultants are also needed during the design and commissioning stages to ensure proper sizing and safety. Altogether, those components and manpower contribute to the economic impact and overall cost of implementing hydroelectric power in Long Sembayang. As you can see from this table, the total cost of implementing a micro-hydraulic system in Long Sembayang, several major costs need to be considered. The first is consultancy, which include the design work, feasibility studies, and technical supervision. For a project of this scale, around 320 hours of consultancy is required, costing about $48,000 ringgit. Next is construction costs, which cover building the intact weir, penstock pathway, turbine foundation, and a small powerhouse structure. As Long Sembayang is a remote and hilly area, construction work is more labor intensive, bringing the cost to roughly around 52 ringgit Malaysia. The equipment costs make up another significant portion of the budget. This includes the turbine, generator, wiring, and control system to regulate voltage and ensure stable electricity. All this costs around 50,000 ringgit. Local labor is also part of the economic impact. We estimated 10 workers over a period of 2 months using Malaysia minimum wage rate. This gives a labor cost around 30,000. And then for transportation, which is another factor, as it is delivered from Limbang to Long Sembayang, which is nearly a 3-hour journey on difficult roads. This adds another 3,200 ringgit Malaysia, and a 10% contingency is also considered to account for inflation, price rising, and unexpected challenges, which cost around 14,000. Altogether, the total estimated cost for implementing micro hydropower in Long Sembayang comes to around 196,000 ringgit Malaysia. This investment provides long-term benefit in the form of reliable electricity, reduced diesel usage, and improved economic opportunities for the community.
The proposed design brings a significant environmental benefit. Firstly, the run-off river design means only a take-out a small fractions of natural river flow is diverted. This prevents habitat flooding, sediment build-up, and major ecosystem disruption. Secondly, the water is returning back to the river after passing through the turbine. It maintains a continuous flow that protect aquatic habitat and support the fish pollution. Thirdly, the system also generate electricity without burning the fossil fuel, helping reducing carbon emissions. Finally, the system need the little maintenance. It means that the local residents can manage it themselves and reducing the visit from the technician and cutting environmental impact. I will end up here, then pass the time to Nicholas.
Thank you, Kelement. Hi, I'm Nicholas. Now I will continue with the analysis for Port Martyrin. So for the economic impact of the proposed solar PV system in Port Martyrin, we are looking at about 60 households, and their total annual electricity demand is roughly about 231,000 kilowatt hours per year. With the condition there, a 115 kilowatt solar PV system is suitable, and it gives us around about 538 kilowatt hours of usable electricity per day. That's enough. That's about enough to cover about 85 to 90% of what the communities need on a daily basis. Next, we are the system costs around 155,000 US dollar to install. That may sound a lot at first, but the savings are huge. So the community save about 150 to 160,000 ringgit every year from not buying electricity from the grid. That gives the system a very fast payback of around 5 years. After that, it's basically free electricity. Over its whole lifespan, the village saved more than 2.5 million ringgit, which makes the system very economically attractive. Next, I will talk about the environmental impact of the proposed solar PV system in Port Martyrin. From an environmental point of view, solar PV is extremely clean. There is no emission during the operation. And for this village, the system helps avoid about 462 tons of carbon dioxide every year. This is also a silent silent and uses no water system, which makes it perfect for a small island like Portuguese that has limited natural resources. The only real environmental concerns come from the manufacturing and end-of-life disposal of panel batteries, but this can be managed through proper recycling and e-waste program that Mauritius already have. Next is because the design we use uses rooftop mounting, so there is no need for land clearing or large solar farms. So the local ecosystem stays undisturbed. Next, I will talk about the conclusion of a project of this assessment. So to wrap up, both communities benefit from the different renewable energy solutions based on their natural conditions. For example, Long Sebayang is ideal for micro hydro because of its river flow, and while Port Maturin benefits much more from the solar because of its strong sunlight and high cost saving. Therefore, in both cases, the solution reduces the environmental impact, lower the electricity cost, and improve long-term energy security for the community. So overall, the renewable systems chosen are the most appropriate and sustainable options for their respective location. That's all for our group. Thank you very much.